So we are taking a look at block 2 of topic 3, patterns in proportional relationships. So we're continuing our journey into looking at proportional relationships. So let's just get started right away. Now, consider a shade of green paint made by using 1 cup of blue paint for every 2 cups of yellow paint. All right. 1 cup of blue paint for every 2 cups of yellow paint. It wants us to, and it says to write a rule that you can use to find the number of cups of yellow paint that you'll need for any number of cups of blue paint, and write your rule in words. Okay. So what we want to find out is how much yellow, how much yellow paint will we need if we know how much blue paint we will need, right? That we're going to use. So I would say here that the thing you would want to say is to find the amount of yellow you would need, you would just, um, whoa, I would say take the amount of blue paint, and multiply by 2. That makes sense, right? Because if you take any amount of blue paint and multiply that by 2, that should get us to the amount of yellow paint that we need. And to make sure that that's the case, let's take a look at this table for part B. It says that the table represents the relationship between cups of blue paint and cups of yellow paint needed to make this shade of green. So let's complete the table. What process did you use to find the number of cups of yellow paint? So, um, yeah, let's have a look at that. All right. So if we take, I'll change the color of my marker here. We take the amount of blue paint to find the amount of yellow paint. Well, let's see. So if we take that and we multiply it by 2, so 2 times 1 equals 2, correct? And if we have 2 cups of blue paint, well, 2 times the 2 cups of blue paint equals 4 cups of yellow paint. Hey, it looks like it's working so far. If we take 2, if we have 3 cups of blue paint, we take 2 and we multiply that by 3, then we would get the 6 cups of yellow paint. Well, that seems to be making sense so far. If we take 4 cups, well, then we take 2, we multiply that by 4, and that'll give us 8 cups of yellow paint. Well, let's go over here off to the side and let's try to create an algebraic rule, because the next question says, what is the coefficient in the algebraic rule? Well, there's no place for us to write an algebraic rule. But so let's say that we've got X for our blue, right? And yellow, we will represent that with our Y, because X is our input, Y is our output. What would our algebraic rule look like? Well, I would think that if we take Y is the number of cups of yellow paint that we need. That would be equal to, well, what do we have to do to our X? What do we have to do to the input, the number of cups of blue paint, to get our output, the number of cups of yellow paint? Well, as you can see, as we follow the pattern down here, 2 times 1 for 1, 2 times 2 for 2, 2 times 3 for 4. I'm sorry, 2 times 3 for 3, 2 times 4 for 4. Well, if we replace any of those numbers with X, then it would be 2 times X. So now we have our algebraic rule, or as we can call it, an equation, right? An algebraic rule is the same thing as an equation, because you've got, an equal sign with something on both sides that should equal each other. Now, maybe you know what a coefficient is, maybe you don't. But the coefficient in an algebraic rule is any number that is multiplied by a variable. And in this case, that coefficient is the 2. So the 2 is the coefficient of x. So what is the coefficient in the algebraic rule? 2. 2, I tell you, it's 2. TWO, 2, or the number 2. That's what the coefficient is, because remember, a coefficient is the number that is multiplied by a variable. And maybe you might want to write that down. Coefficient. A number that is multiplied by a variable. You definitely want to variable. There we go. You definitely want to write that down if you haven't gotten it written down somewhere, that a coefficient is a number that is multiplied by a variable. So does this algebraic rule, whoa, sorry about that. Don't mean to get all crazy with you. Does this algebraic rule make sense for this scenario? Well, if x is the number of cups of blue paint, and we multiply that number by 2 to get the yellow paint, well, then it should make sense, because the amount of yellow paint is always 2 times more than the amount of blue paint. So yeah, we like that. That's a good one right there. Because there is always twice as much yellow paint as there is blue paint that gets used to make this shade of green. It must be very bright green. Now, question E. What would happen if you had 0 cups of blue paint? How many cups of yellow paint would you have? Well, let's see here. Remember, y is equal to 2x, and x represents our number of cups of blue paint. So if we replace that x with 0, then that would be 2 times 0 equals y. And so, of course, that means that 2 times 0 is 0. So how much yellow paint would you need? 0 cups. Because if you don't use any blue paint, you're certainly not going to use any yellow paint to make that shade of green. So that means 0, 0 is one of those points on a graph that this would pass through, meaning that it's a proportional relationship. Passes through the origin, and I'm willing to bet it's a straight line, because it's always y divided by x is always 2. So that's pretty cool, right? We can always find the coefficient. If we look at a table, we can always find the coefficient, right, of that coefficient there is always, you'll notice that in this case, the coefficient of x is also the constant of proportionality. That's important. When we have a proportional equation like this, an equation of a proportional relationship, the coefficient of x is the constant of proportionality, meaning you will always multiply your x times that number to find the y. Very nice. Very nice indeed. Okay, well, let's look at question number 2 then. Don't see any question marks in the chat, so I think we're doing good so far. Remember, all you have to do is type a question, and I will stop the recording and answer your question before moving on. So let's look at question numero dos. Now consider a different mixture for making green paint. This paint mixture requires 3 cups of yellow paint for every cup of blue paint. So complete the table and graph for this paint mixture. All right, well, to get 1 cup of blue paint out, and we need 3 cups of yellow, what do we do here? Well, we have to multiply, looks like we multiply 3 times 1 to make that 3, right? We need 3 cups of yellow for every cup of blue. So if we have 2 cups of blue paint, we multiply 3 times 2, and that gives us 6. So remember, that's our x, And our y, our input and our output. For 3 cups of blue paint, we would take 3 and multiply it by the 3 cups of blue paint that we have. And that makes 9 cups of yellow paint. For 4 cups of blue paint, we're going to multiply 3 times those 4 cups that we've got. 3 times 4 is 12. Okay. Now this last bit, oh, you know what? They want us to graph it first. Let's graph that thing. Let's just assume that on this graph, we are, you know what? Oh, yeah, we'll use green. Green is good. And those are good sized dots. Okay. So 1 cup of blue would be 1, 2, 3 cups of yellow. Zoop. And 2 cups of blue would be 6 cups. 3, 4, 5, 6. Uh-huh. And 3 would be 9. Uh-huh. And 4 would be 12. Yep. And I would be willing to bet that if we connected those dots, it would be a straight line that would pass through the origin. What do you bet? Let's find out. Whoops, you got to start at the origin, Mr. Eaton. Sorry about that. Be better if I use my mouse. Make sure I go through each of those dots very carefully. Look at that. A thing of beauty is a joy forever. Look at that graph. Look at that graph. Okay. You just have to remember what it is that this stuff is representing. Remember, this is down here, this is our x-axis, and this is our blue paint cups, right? The amount of blue paint. And hold on a second here. This is our y-axis, and that's our yellow axis. All right. Now they want us to write an algebraic rule that represents the relationship between the cups of blue paint and the cups of yellow paint. You've got to remember when you're writing algebraic rules, that's an equation, okay? So again, we put our x here, and what is our rule to get to our y? What do we have to do? What did we do in every one of these? What stayed the same in this? The 3 stayed the same, but what changed in every row? It was the amount of blue paint. And so we would say, all right, well, we would multiply the number of cups of blue paint by 3, and that would equal the amount of yellow paint that we have. So when we go to write our algebraic rule, and please remember that these algebraic rules need to be written in a very uniform manner. So the amount of yellow paint that we would need is equal to the amount of blue paint that we have multiplied by 3. There is our algebraic rule for this particular graph. Okay. Now, this brings us to the next really cool part. And that is in question number 3, it says we're going to use the work in question number 2 that we just finished to answer the following questions. Using this algebraic rule that we just wrote, the algebraic rule right there, algebraic rule, otherwise known as the equation. Oh, forgot my A. There we go. Calculate how much yellow paint should be added for 8 cups of blue paint. Okay, so let's do this. Since it's an algebraic rule, let's do it algebraically. Let's write the equation first. Y equals 3x. We want to know how much yellow if we're using 8 cups of blue. So we can replace the x in this equation with 8 because x represents the number of cups of blue paint. So the amount of yellow paint that we need is equal to 3 times 8, which is 24. So we would need 24 cups of blue paint. I'm sorry, yellow cups of yellow paint. Sorry about that. You're probably like, what are you talking about, Miss Reed? Yellow paint. We would need 24 cups of yellow paint if we used 8 cups of blue. Okay. I don't see any question marks in the chat yet, so I'm guessing we're good to go. Remember, these algebraic rules need to be written very specifically. That takes us to question B, 3B. It says, well, if you had 21 cups of yellow paint, how many cups of blue paint will you need? Well, so now remember, we still have the same equation, right? Y equals 3x. But in this case, we know how much yellow we have. We have 21 cups of yellow. So we can substitute that, the cups of yellow paint, with 21. But we don't know the cups of blue yet. But with 21 equals 3 times x. We can solve this. This is a one-step equation. Solving a one-step equation, well, it's just the simple matter of undoing what's been done, because we learned this already. Divide both sides by 3. That 3 cancels that one out. And x is equal to 21 divided by 3, which is 7. So you can see you can use this equation, this same algebraic rule, the same proportional equation, to find out how many cups of blue or how many cups of yellow if you know the other amount of the other color. It's a beautiful thing. Like I've said before, a thing of beauty is a joy forever, and a really well-written equation can be used for lots and lots of things. So we would need 7 cups of blue. All right. Well, I think that's about all that we have time for in this lesson. So I'm going to